Hello! In this video, we're going to be looking at formulation and solutions of systems of linear equations in two variables. That sounds much scarier than it really is. These are situations where you get a couple of different equations with multiple variables that you don't know but you need to figure out, but you can kind of use them to figure each other out. And that is literally this chapter in a nutshell. This is something that correlates with section 5.2, chapter 5.2, same difference. Formulation and solution of systems of linear equations in two variables. Super scary sounding. Not bad. This is in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. And in this video, we're going to be going through one of the problems that an instructor has recommended to us. I think it's a fun problem. It's a little different. It is something that you would typically see. And this is problem number 27. And let's start by reading off the problem, and then we will go through and get it solved. Tom, Dick, and Harry are being questioned by the police after a robbery at a local fruit market. All three fit the descriptions of the fruit thief, and all three were seen at the market. The police ask each what he bought and how much he paid. Tom says he bought 20 apples and 20 oranges and paid $8. Dick says he bought 15 apples and 5 oranges and paid $6.75. Harry says he bought 10 apples and 25 oranges and paid $11. After a short pause for computational purposes, the police released Dick and Harry but kept Tom for additional questioning. Why? Well, my very first thing with these kinds of problems is to write everything we know down. So let's go ahead and start. And I'm going to do something a little different because we're using oranges here, and I'll kind of explain it as I go. So what do we have? We have Tom, Dick, and Harry. Okay. And Tom's kind of the one we're worried about. We just want to make a note of that. Not a huge deal now, but that's the one we want to make a note of. And we have apples. So we know they bought some apples. We know they bought some oranges. And we know how much they paid. So if you'll notice, the first thing I'm doing, I'm making a chart. This is often the easiest way to get all your information out there in an easy way to do it. So Tom bought 20 apples, and I'm going to make my zeros with the slash through it so we don't get confused with zeros and O's. 20 oranges, and he paid $8. Okay? And then Dick bought 15 apples, 5 oranges, and he paid $6.75. Okay. And Harry bought 10 apples, 25 oranges, guy likes his oranges, and he paid $11. Okay, so this may not seem like it, but they just gave us 3 different equations. So let's actually write them down like equations. So we have Tom. Tom's equation is 20 apples, and I said I was going to do slashes, and I meant it. So that's what those slashes mean. 20 apples plus 20 oranges equals $8. And we're just going to put 8. Okay. Dick is 15 apples, 5 oranges, and that equals $6.75. And don't forget, I'm going to actually, so we're totally sure, these are oranges. Okay? Oranges. And then finally, we've got Harry, and he got 10 apples plus 20 oranges, and he paid $11. So that's not so bad, is it? You know, we've got 3 different equations, and we know we have suspicions. There's something not quite right about Tom, or at least that's what the cops are thinking. So let's go ahead and figure that out. And the first thing I like to do is I just like to go down and let's solve this like we would any problem where we know at least 2 different equations using 2 different variables. So you can solve as many equations. Let me rephrase that. You can solve for as many variables as you have equations that are different using those variables. So it's kind of a cool trick. Let's go ahead and start with Tom's. So what I'm going to do first is I'm going to solve for A. And we're going to solve for A in terms of O. And I'm going to show you how you do that. So for Tom's equation, we know 20 apples plus 20 oranges equals 8. Okay, so then we can do 20 apples equals 8 minus 20 oranges. Okay, and then apple equals 8 minus 20 oranges, and that whole thing over 20. And if we wanted to make it as simple as possible, we'd say that this is 40 cents minus oranges, right? Because you can, 8 divided by 20 is 0.4, and 20 divided by 20 is 1, so that's what that turns into. So that's Tom's equation. We just solved for A, so we can plug this value that we got for A into somebody else's equation. So let's go ahead and plug this value into Dick's equation. So we have 15A plus 5 oranges, O, equals 675. Okay, so we're going to go ahead and plug this thing into this A, because we can do that. That's the nice thing about these problems. All they're saying is you can use different stuff and plug it in. So this is 15, and this is times 0.4 or 40 cents minus orange plus 5 orange equals 675. I'm running out of room because I got big handwriting. And so let's do our multiplication. So 15 times 0.4 is 6 minus 15 oranges plus 5 oranges equals 675. Well, okay. So let's see, 6 minus 10 oranges, right? Because we can combine these two right here, equals 675. We subtract both sides by 6, and that gives us negative 10 oranges equals 75 cents. And, you know, I don't know if you're noticing this, but this is a problem right here. All of a sudden, the price of our oranges has to be negative. And I have never been to a store where they pay you money to take oranges. So that tells me that there's a problem. And we know that that's okay. In this problem, they've said, hey, we're kind of suspicious for the numbers Tom gave us. And we could stop right now. We could say, however, Tom's math doesn't work with Dick's math. Somehow when you put Tom and put Tom's value for apples into Dick's value for apples, you start getting a negative number. Now, we could say that, but that's not enough to prove it. So what if the shenanigans are happening on Dick's side? So let's go ahead and plug this in for, let's go ahead and do the same thing, only instead, this time we're going to use Dick and Harry's formulas. So just so you remember, Dick's formula is 15A plus 5O equals 675, and we're going to solve, we're going to go ahead and solve for A here, and you don't have to, you could solve for orange, it's totally up to you. So this, I mean, I'm going to jump over some of the algebra. So this is going to be 675 minus 5 oranges over 15, and I'm going to leave this as a fraction for right now, because things start getting kind of nasty if you try to take it out of the fraction. So we're going to plug this A into the A in Harry's equation. So Harry's equation, just so we remember, is 10A plus 25 oranges equals $11. So let's go ahead and plug this A, let's change the color again, this A in here. So all this stuff gets plugged right in there. So let's go ahead and do that. Plugging this value in for A gives us 10 times 6.75 minus 5 oranges. Whoops, I keep forgetting my slashes. Over 15 equals $11. Okay, so let's keep on keeping on. whoops, I'm missing some stuff. I'm getting excited and I'm moving ahead. So we actually need, you got to remember to keep everything in there. This ends up being plus 25 oranges equals $11. Okay, so let's keep on keeping on. So let's see. 675 divided by 15. It may not seem like it, but that actually is pretty nice. That ends up being 45 cents. Minus, and we're going to go ahead and keep on with the fractions, but we're going to bring them out a little bit. So that's minus 5/15 oranges plus 25 oranges. And I'm not saying like they have 25 oranges. This is the value of oranges. This is how much it costs to get oranges. So, okay. So keeping on. Now we're going to multiply this 10 into everything. So we've got 450 minus 50 over 15. Actually, I'm going to go ahead and cheat because it's a little easier to do it this way. 5 over 15 is 1/3, so 10 times that is 10 over 3. Oranges plus 25 oranges equals 11. So we're going to keep on going. Let's see. Minus 10/3 oranges plus 25 oranges equals, and so this is 11 minus 450, and that is 650. And this is basic algebra at this point. So again, you know, we're just seeing, are the values that Dick and Harry put together, do they actually end up being legit values? You know, we want to make sure that there's not a case where somehow somebody's getting paid to take some oranges. You know, something about Tom's prices don't add up, and that's what the cops are looking at here. So let's keep on going. So this turns into doing a little bit of quick math, and you could do this a couple of different ways. We'll do it 65 over 3, and that's because 25 times 3 is 75, minus 10, 65. Oranges equals 650. And if we go ahead and continue, you know, doing the math, multiply 650 by 3 over 65, we get oranges equal 30 cents. And that is a legitimate cost for oranges. So let's zoom out and talk about why we proved that Tom's math is a little shady. Now that doesn't mean he's the thief, but that does mean something's not quite right. So what did we do? Well, the first thing we did is we made a chart of everything we know. Okay? Very first thing, write down what you know. The next thing we did is we figured out what are the equations that this gives us, and that lets us figure out the values for A and O, or apples and oranges. Then what we did is we chose one, and we started with Tom, and we solved for one variable, in this case A. So we did the math, we got a value for A right here. And then we plugged that into somebody else's formula. And in this case, we plugged it into Dick's formula. And when we plugged that in, we did the math, and then all of a sudden we had a problem. All of a sudden, the value of oranges is negative, and that's a problem. It's not necessarily that this right here has a negative sign. It's that a negative times something to equal a positive, well, the oranges have to be negative. So some basic algebra there, but you want to make sure you're comfortable. So that's a problem. That is a red flag. So at that point, we backed up, and now we're looking at Dick's equation right here, and we solved for A. We plugged that into Harry's equation. We did some math, did some math. There's a lot of math doing here, and then we got an answer, and that's a legit answer. And if you really, really wanted to prove this out, then you'd then go ahead and plug this O back into the equation we got for Dick, which was A equals 675 minus 5 oranges, that's an O, over 15, and we could plug this back into this O, and I think that's 35 cents-ish or somewhere in there. But the point is, it's a legitimate value. That is actually a cost. And so there's a couple of different layers to this problem. It's kind of a puzzle. You want to be looking at, you know, what kinds of values are okay. So since we're talking about price, it's going to be positive. You want to find out all your different values, and then you want to figure out how they all relate to each other. It's not so bad. Do some more practice. Try to set up some problems with a couple of different variables in them. I think you'll find them a little intimidating looking, but not as bad as they look.